This video will look at limiting and excess reactants. So the objective of this video is that you will be able to identify both the limiting and the excess reactant in any chemical equation with 100% accuracy. So before we begin, let's start with the definition of limiting reactant and excess reactant. A limiting reactant, also known as a limiting reagent, is the reactant in a chemical reaction which is completely used up. And the excess reactant, as the name suggests, is the reactant in a chemical reaction which is left over once the reaction has stopped. So let's go ahead and think about this. I've reacted magnesium pieces with hydrochloric acid. So magnesium pieces and hydrochloric acid. After the reaction stopped, I noticed a solid left at the bottom of the flask. So which reactant limited our reaction? To figure out which one limited us, we need to determine which of the reactants was completely used during this reaction. Well, hydrochloric acid is the one that limited us. How do I know that? Because the magnesium pieces were still visible at the end, which means magnesium was left over, or the excess reactant, which makes hydrochloric acid our limiting reactant. Okay, let's do this again. You have reacted baking soda and vinegar in a beaker. So baking soda and vinegar. After the reaction stops, you can't see any powder at the bottom of the beaker. It just looks like a liquid or a solution. So which substance was the limiting reactant? Think about it. Baking soda limited our reaction in this case. How do I know that? Because there was no solid visible at the end of the reaction. If there was no solid visible, that means the baking soda, the powder, was completely used up and there must have been some vinegar left over. So in this case, the baking soda was the limiting reactant and the vinegar was our excess reactant. Now, we can also figure this out with a calculation instead of just through concepts. So we're going to do that right now. If 50 grams of calcium reacts with 50 grams of water to produce calcium hydroxide and hydrogen gas, what is the limiting reactant? Well, before we can do anything, we are going to need a balanced chemical equation. And here it is. Now let's go ahead and look at what the problem tells us. We see 50 grams of calcium is reacted with 50 grams of water. So I'm going to go ahead and label these. We want to know what the limiting reactant is. So is calcium limiting us or is water limiting the reaction? Now, here's a side note. It doesn't matter which product we choose to convert to. So whether we want to convert from grams of calcium to grams of calcium hydroxide or grams of calcium to grams of hydrogen gas, it does not matter. We just have to make sure we're using the same product for both calculations. So I'm going to go ahead and set this up. To work this problem, we are just going to perform a grams of X to grams of Y conversion. And we're going to have to do it for each reactant, for calcium and then again for water, and compare the two. So we start with 50 grams of calcium, and we don't use this bottom section. The first step is grams of calcium to moles of calcium. We divide by molar mass. Then moles of calcium to moles of, I'm going to choose to convert to H2 because this looks simpler. And there's a 1-to-1 mole ratio. There's a 1 in front of calcium and a 1 in front of hydrogen gas. And finally, we're going to convert moles of H2 back to grams of H2. And when we do this, we'll find the answer to be 2.5 grams of H2 can be produced from 50 grams of calcium. Now let's do that again for the other reactant, which is water. So 50 grams of water, and same process. We're going to convert grams of water to moles of water. Then we're going to use the mole ratio to convert moles of water to moles of hydrogen gas. Note that I am using the same product when I convert the water and the calcium. And last, we're going to convert moles of H2 to grams of H2. Do this math and we find 2.8 grams of H2 can be produced from 50 grams of H2O. So now we need to compare these two. And we immediately see that this value is smaller. So the calcium can produce less hydrogen gas than the water. Because we see that that is true, we know calcium is the substance which limits the production of hydrogen gas. So because the calcium can only produce 2.5 grams of H2, we know calcium is our limiting reactant and hydrogen gas is, and the water is our excess reactant. Okay, example 2. 50 grams of magnesium hydroxide reacts with 50 grams of nitric acid according to the reaction below, but I did not write it for you. You will need to write it. So which substance is the limiting reactant? Y'all pause the video and try this on your own. Okay, and here is the answer. So this is what your equation would look like. Now we're going to set up our tables. So yours should have looked like this. We're going through it quickly. Let's set up the second table. And this is if you chose to convert 2 grams of water instead of grams of magnesium nitrate. Okay, so we see here that the 14.3 grams of water is a lot less than this 30.9 grams of H2O. So this must be the substance which limited us because it produced less water than our magnesium hydroxide. That makes nitric acid our limiting reactant and magnesium hydroxide our excess reactant. Thank y'all for watching.